Welcome to Knowledge Search channel, and in this video we will be discussing about a moving coil, or it is also called as PMMC instruments. So we were in earlier videos we were discussing about the measurements and instrumentation based topics. If you are new to this field, you can just watch the previous videos and come back. That is basically any instrument is used to measure a quantity like ammeter or voltmeter. It is used to measure the current and voltage. So there are two types of electrical quantities. One is AC and DC. So this particular moving coil is suitable only for measuring a DC quantity. It is not suitable for measuring an AC quantity. So why it is so, we will be discussing in this. So in this I will just brief about what are the different types of instruments. Okay, so basically the analog instruments. Okay, as you all know, the analog instruments are playing a very vital role for high power application. The digital instruments may be playing very vital role in the low power instrumentations, whereas the analog instruments are still having its hold in high power applications. So it is broadly classified into two different types. One is the MI instrument, which is called as moving iron. So in this case, what is going to happen is the iron core is going to move according to the magnitude of current. It is going to deflect, okay, and because of which the point which is attached to the iron core will be deflecting. That is why we are moving iron. So iron is getting moved. So that is why it is called moving iron. Whereas the today's topic is about MC instruments. What is it? MC, moving coil. So a coil is there. That coil is going to move according to the magnitude of current. If the magnitude of current is very high, then the coil will be deflected very high, and because of which the point which is attached to that particular coil also will be deflecting high. If the particular coil is energized with less current, then the deflection will be less, and because of which the point will be moving to a very low value, indicating the low magnitude. Okay, so this is called as MC instruments, that is moving coil. Moving iron is different from moving coil. As we have discussed in the previous video, moving iron is suitable for measuring both AC and DC, but it is not suitable for measuring DC because it is quite inaccurate for DC measurements. That is, MI instruments can measure both AC and DC, but it is not accurate for DC measurements, which we have discussed in the previous video. So in order to have the accurate measurement of DC values, we are using the MC instruments, that is moving coil instruments. It is the other name of moving coil instrument is PMMC. MC is okay. What is it? PMMC. See, in all the moving coil instruments, we have to use a permanent magnet. Only then it will work. Okay. In all the MC instruments, we have to use a permanent magnet. Only then it will work. So that's why it is called as PMMC in short, which is called as permanent magnet moving coil. See, earlier it was called as MC instrument. Since we have to use permanent magnet in all the MC instruments, in short it was called as PMMC instrument. PMMC is a permanent magnet moving coil instrument. Okay, that's all about the introduction. And again, I just want to convey here that this particular instrument will give an accurate reading only for DC measurement. It is not suitable for AC. For AC measurements, you have to go only with the MI instruments. For DC measurement alone, you have to go with the MC instruments. MC instruments gives accurate value for all the DC measurements. For example, DC current, DC voltage, everything will be accurately measured in PMMC instruments. So let us go. How this video will look like is like, first we will be discussing about the construction and working of this PMMC or MC instrument. Okay, what is the construction of what are the different parts in this particular instrument, and how it works, and how the deflecting torque is produced, how the control torque is produced, how the damping torque is produced. As you know, these three torques play a very vital role in any instrument. A deflecting torque will be proportional to the amount of magnitude of current that is passed to that particular instrument. A control torque is nothing but it will be having a spring attached to that particular spindle, and that spindle will control the torque, okay, so that particular point will settle to a particular value. Okay, if the deflecting torque is very high, then it will settle to then that particular pointer will settle to a high value. If the deflecting torque is of less value, then it will settle to a less value. Okay, so the controlling torque plays a very vital role. As well, the third one is damping torque. What is damping torque? We have discussed in the previous video. Damping is nothing but there will be some overshoot and undershoot, and finally it will be settling. Okay, so it will take more time to settle. So the pointer will be oscillating over the scale. So in order to and finally it will be damping. So initially the oscillations will be high, then slowly it will reduce, and then it will go to the stable. So that particular oscillation has to be damped very fast. If it is not damped, for example, if the oscillations of the particular pointer over the scale is for more duration, then that particular pointer and that particular instrument may get damaged and its life can be reduced. So always the damping torque plays a very vital role in improving the life of that particular instrument. Okay, so the damping torque can be produced by many techniques. So in this, how this damping torque is produced. So here we will be discussing about the deflecting torque, controlling torque and damping torque, how it is produced. Okay, first we will be discussing about the construction, then we will be discussing about the working, then we will be discussing how this control torque, deflecting torque and damping torque are produced. So finally, then we will be discussing about what are the errors that are involved in this particular instruments and what we have to be more cautious, and then we will be discussing about the advantages and disadvantages of the PMMC instruments. Okay. So for example, I just want to convey here, this particular PMMC works with a motoring principle. What do you mean by motoring principle? So in case of motor, what is going to happen? Whenever a current carrying conductor is placed in a magnetic field, okay, whenever a current carrying conductor, in motor what happens? Whenever a current carrying conductor is placed in a magnetic field, which is produced by the permanent magnet, then the coil will experience a force and hence the particular coil will move. Is it right? That is called as a motoring principle. So in case of motoring principle, a current carrying conductor is placed inside a magnetic field. Whenever a current carrying conductor is placed in a magnetic field, it experiences a force. Okay, and that force is given by the Fleming's left hand rule. All those things we have discussed. Okay, in your earlier +2 itself, you know. Okay, whenever a current carrying conductor is placed in a magnetic field, it experiences a force, and that particular force is used to move the pointer in this case. So this is the basic principle of working of the PMMC instrument. So it is nothing but a motoring principle. So in this case, why it is called as moving coil? Because the coil is moving. Okay, because the coil is moving according to the magnitude of current. So hence it is called as moving coil MC. That is MC. Why it is called as PMMC? So we need a permanent magnet. PM in short, it is called as permanent magnet. So permanent magnet, without permanent magnet, there is no moving coil instrument. So all the moving coil instruments are having permanent magnet inside it. So that's why it is called as PMMC, permanent magnet moving coil instrument. Okay. So here the force experienced by the coil is directly proportional to the current passing through the coil. So this is what you want to remember. Okay. So now let us move on with the diagram and let us go on with the discussion of the different parts, and then that is the construction, then working, and then we will discuss about the different how the torques are produced, how the three different torques are produced, like deflecting torque, control torque, damping torque, or how they are produced, and then we will discuss about some errors and advantages and disadvantages, and then we will close this session. Okay. So here we are having the construction. So this is the top view. So I will just mark it. Okay. So this is, I am just marking it with the violet color. So here, so this is the this is the side view. Okay. So this is the side view of the PMMC instrument, and this one I am going to mark in green. Okay. I am just going to mark in green, and this is the top view. Okay. So this is the top view, and this is the side view. Okay. I will just again side view. Okay. Side view means you are going to look from side. Okay, so that is what, this is the side view and this is the top view. So for example, if you are seeing from the top, that is called as the top view, and if you are seeing from the sideways, it is called as the side view. So it is both the same instruments. Okay, both are the same instrument. The views are different. For example, the first figure shows the side view, the second figure shows the top view. So this is the figure which is marked in violet, it shows the side view, whereas the figure which is marked in green shows the top view. So let us discuss one by one in detail. Okay, let us go into the detail, right? How it works and what are the different. So construction. So here you can see that the moving coil, it is rectangular in shape. Is it right? So rectangular in shape, and it has number of turns of wire, okay. And this moving coil is placed in a permanent magnet, and also it is of horseshoe shape, okay. It can be of horseshoe shape, and you can see that the iron core is of rectangular shape, okay, and over which the moving coil is placed, and due to this iron core the deflecting torque will be very high, okay, and also the sensitivity also is very high, okay, and the controlling torque is produced by the spring, okay, which is made up of the phosphor bronze, okay. And finally the damping torque is provided by the aluminum, which is placed above the moving coil, and because of which, that is the permanent magnet, that is the magnetic field will be higher, okay. So the pointer connected to the spindle moves on a uniform scale. So whereas in case of MA instrument it was moving in a non-linear scale, here it will be moving in the uniform scale. And here an error, a mirror will be placed below all the pointer, so that is called as parallax error. So we have to see in parallel. Anyway, I will be coming to it later, okay. And a balance weight is also used in order to improve the damping, okay, and also a deflection of the pointer here is proportional to the amount of current that is passing through the coil, okay. So this is how the construction is all about, okay. So here, so I will just explain once more, okay. So here you are having that is a coil is there, okay. So this is the core, so this is iron core. So here also the iron core is used, okay. Over the iron core, you can say that this is the marked in the dashed lines, okay. Iron core is there, a coil is there. So that's why the coil is wounded over the core. So here you can see that the coil is the second one, and the entire thing is embraced into an aluminum frame. So this is how it looks like, and this is a horseshoe magnet. So again you can see that a permanent magnet is used, okay. So this is the permanent magnet, a permanent magnet is used, that is north and south is there, okay. So here north, here south. So this particular core and this particular coil and this particular aluminum frame, everything is placed inside the magnet, and all are placed, this particular that is the core and everything is placed on a spindle, okay. This is a vertical thing which is going to carry over that, and you can see that the pointer is in horizontal. You can see that the pointer is horizontal, okay. So this is your pointer, I am just marking it in brown color. So this is your pointer, so pointer which is moving over the scale, okay. So this is your scale, okay, this is your scale, this one, okay. So this is your scale. So the pointer will be moving over the scale, it will be oscillating, okay, it will be oscillating. So you have to control the damping. So in order to prevent the damping, that is in order to improve the damping of oscillation, you have to use a balance weight, okay. So this is how. As well, some spring is also used in order to improve the damping. So this is the spring, and balance weight is used to improve the damping, that is to reduce the oscillation, okay. Finally it will be all are connected in one single point, that is unpivoted, and that bearing used is jewel bearing will be used, okay. So this is how the construction look like. So it is very simple. You are having an iron core, and over the iron core a coil is placed, and this coil, over the coil core an aluminum frame is there in order to equip all the things, and all are made to move inside a magnetic field, okay. So already I have explained how it works. So how it works actually? So how it works? So here whenever a current carrying conductor, so here the current will be flowing through this, okay. This is what the current is flowing, okay. Here I am marking again in brown. So this, in this coil the current will be passed. If the current is flowing through this particular coil, okay, whenever a current carrying conductor is placed in a magnetic field, so you can see that the coil is placed inside a magnetic field, it will experience a force, and what this force will do, it will move the spindle, okay, it will move the spindle, and because of which the pointer which is attached to the spindle will also move, and because of which some deflection will be there, and because of which that particular reading can be measured over the scale. Is it clear? And this balance weight and springs are used in order to produce the damping torque, in order to reduce the oscillations, okay, in order to, that is what damping. So the control torque is produced by the deflection torque is produced by the magnitude of current, and the control torque is produced by the spring, okay. So this TC, that is the control torque, is produced by the spring, okay. I will mark it as TC, and this balance weight is going to produce what? it is going to damp the oscillations, okay, that is I marked as TD. And deflecting torque, so this the core is going to produce the deflecting torque, that is T deflecting, okay. According to the magnitude of the current, the deflection will be high, because the magnitude of current decides the amount of deflection. If the magnitude of current is high, the amount of deflection will be high, the spindle will be moving more, and because of which the point also will be moving more, which shows higher magnitude on the scale. If the amount of magnitude of the current in the coil is less, then the deflecting torque will be less, and because of which the spindle also will be moving only to a very less angle, and because of which the point also will be moving in a very less scale, okay, of the less magnitude. So this is how it works. Is it clear? So this is the overall working of the PMMC instrument, okay. It's very important, okay. In most of the question paper you can expect this particular thing. So here you can see that this is the top view. So again this top view you can see, in top view you can see that, so this is the pointer which will be over the scale, okay, and the point will be moving, and here you can see that, okay. So one more thing I just want to convey here, what are the errors, okay, what are the errors? See here it is using permanent magnet. So you can see that the errors are very less, okay. There are no much errors, okay, since the permanent magnet is used, the errors are very less. So the thing is, as you go, the life is high. For example, when the PMMC instrument is used for nearly 5 to 6 years, the permanent magnet will become slightly weaker due to aging, and because of which the reading may be quite error. Okay, this is one type of error. The permanent magnet will weaken due to aging. As well, for high temperature, this permanent magnet will not work efficiently. This is one more problem. So if you use the PMMC instrument in high temperature zones, the permanent magnetic field will get disturbed, and because of which the point of deflection also will get changed. Okay, and also the spring which is attached, okay, it is also going to weaken due to aging and temperature. So these are all some of the errors which are possible. Okay, the main advantage of PMMC is it is using a uniform scale. So and also the power consumption is very less. Okay, it takes just about 25 microwatts. Just 25 microwatts is the power consumption of any PMMC instrument. Accuracy is very, very high. Sensitivity is very, very high. That is, a small value of current also can be easily identified. So sensitivity is very good, accuracy is very good, power consumption is only 25 microwatts, uniform scale is there, damping is pakka, because here we can use eddy current damping. See, in case of MA instrument, we used only the air friction damping. Why we used air friction damping is because if we use any magnetic field in the MA instrument, then that will disturb it will cause an error. But here, since we are using the permanent magnet itself, the damping can be made using the eddy current damping. So it is not affected by the external magnetic field. So this is one of the main advantages of the PMMC. Uniform scale, low power consumption of 25 microwatt, high accuracy, high sensitivity, and the damping due to eddy current is very good, and high quality damping is achieved, and it is not affected by the external magnetic field. So what are the drawbacks? The drawbacks is very costly, because we are using the permanent magnet. It is very costly. Okay, and main drawback is it can be used only to measure DC. It cannot be used to measure AC. Okay, why it cannot used to measure AC? That's a different story. I will come to it. Okay, why it cannot be used? See, here there is a small derivation in books you can see, and finally this theta is nothing but the deflection. This theta is nothing but the deflection of the pointer. So deflection of the pointer is directly proportional to I, whereas in case of AC you can see that the current will be moving positive as well as negative. Okay, one half cycle it is positive, the other half cycle it is negative, and because of which you can see that the deflection also will be in positive and negative directions, and because of which the PMMC pointer will get confused and it will not move. Okay, that's what is going to, only the heating will be there. So the current produces, that is here, that is the deflection theta is directly proportional to current in case of PMMC, whereas the deflection theta is directly proportional to I square in case of the MI instrument. So since it is I square, so negative values come also. If it is squared, what is going to happen? Again, it is going to be positive. So that's why MI instrument are used for AC as well as DC, whereas PMMC instruments, that is moving coil instruments, can be used only for DC. It is not applicable for AC. Okay, so this is what I just want to finally conclude. So in this video I have discussed about the construction of PMMC, working of PMC, and what are the different tasks that are available in PMMC, and why it is not suitable for, why this PMMC instrument is not suitable for AC measurement. So this is all the discussion is all about in this video. So coming to the end of this session, I am okay. So if you really like this video, give a thumbs up, and if you have any queries, you can just comment. And if you really want to share that this particular video will be useful to someone, you can just share it. And please subscribe to my channel by giving more subscription. I will also be putting more videos, more such videos in this channel. Thank you.